everyone. Once again, good morning to all. Welcome all on this uh, n- latest Tech Talks episode. Sorry for starting late. There were some technical issues. Okay, let me start and quickly introduce about Gyaniki and Tech Talks, and then we will hand it over to our today's speaker. So, once again, thank you all. Gyaniki is a division of the Rumble, as you already know, and which is a comprehensive knowledge platform dedicated to the automotive and advanced mobility sector. Now, this platform aims to bridge the knowledge gap in the rapidly evolving automotive industry, and especially in the context of electric vehicles and the advanced technologies. So in Gyaniki, we cover a database of manufacturers, suppliers, technologies, key players of the mobility sector, and especially those who are working into the electric, autonomous ADAS, connected and shared vehicle technologies. So as we know, in today's era of artificial intelligence and machine learning, we are really surprised to see how it can help to evolve the EV industry, right? In today's Tech Talks, we are going to know some interesting insights how AI can help to diagnose the EV batteries to improve the overall safety and its performance. So, I am very excited to introduce our today's young and dynamic speaker, Shubham Mishra. He's a founder and chief experimenting officer of Battery OK Technologies and MTech from IM Ahmedabad in energy infrastructure. He has founded the company called Battery OK in 2019 and redefine the mobility with user-friendly AI-driven solution in like an EV doctor. Now, this is the world's fastest battery testing technology, which is being claimed, and he has a really great experience in multiple organizations, right? Under his leadership, Battery OK collaborated with the giant EV giants like Tesla, MG Motors, Maruti Suzuki, Mahindra Electric, Hero Electric, and many more. Let's see what he has to share with us today. Again, thanks Shubham for joining, and you can switch on your camera or you can share your screen to share your presentation. Thanks once again. You can start. Over to you.
We will start with the development of lithium-ion batteries, and gradually we will be moving towards the diagnostics part of it. Okay,
Yeah.
let us see the history of batteries. So the term battery was coined by Benjamin Franklin, sir, in 1748 around. Then lead acid batteries came, nickel cadmium batteries came. So these were initial rechargeable batteries. And in 1988, first lithium-ion battery was made in a lab in USA. And in 1992, it was commercially available. In 1999, lithium polymer batteries, which were like for smaller form factors, were introduced. And in 2006, lithium ferrous phosphate, that is LFP batteries, were introduced, which were having good lifespan, good safety, good energy density. So, in this way, the lithium ion battery scope evolved over time. Right now, the batteries are more uh, focused towards the portable applications, towards the high energy density and low power density applications. Okay, so here you can see that there are two major components for a battery, anode and cathode. Anode decides the charging time of the battery. So whatever components that we are using in the anode will decide the charging time of the battery. Most of them are using graphite on the anode side, whereas on the cathode side, we normally use lithium, nickel, cobalt, or manganese. These are rare earth metals and they decide the cost and range of the battery. Okay, there is a separator in between which acts as a separator, you can say, for the electrons and the ions which are moving from anode to cathode and cathode to anode during charging and discharging process respectively. So let's brush up some basics: voltage, capacity, energy density, and power density. So voltage, we know that it is the electrical potential. Capacity is the amount of energy that can be stored in a particular battery. Energy density and power density has more to do with its size and the speed at which the energy transfer happens. So if the energy density is high, that means high energy can be stored in a particular volume. And if the power density is high, that means the power transfer will be higher per unit time. Okay, so if power density is high, that means the charging time will be good or faster. Whereas if the energy density is high, that means higher energy can be stored per volume. Okay, so these are some types of lithium chemistry batteries which are normally used. I'll share the uh, presentation where you can see it clearly. Right now, in India and across the world, LFP batteries and NMC batteries are used. LFP batteries are called lithium ferrous phosphate, and NMC batteries are normally called as lithium ion batteries or nickel manganese cobalt batteries. The key makers I have already listed. What's the key difference? The number of cycles. Okay. Apart from that, if we consider what's the exact difference between LFP and NMC batteries, then it's not just the number of cycles, but also the lifespan and the safety that is guaranteed more on the LFP side, but not on the NMC side. So initially, NMC batteries were used for high energy density applications, but due to low safety and low thermal stability, LFP batteries were performing better. That's why right now the whole EV industry, or you can say the energy industry, is shifting towards LFP batteries. Now let us understand how the designing of lithium-ion battery pack system. Okay, so when we say 18650 cells, that means there is a meaning to it. 18 and 65 is the dimension. So that dimension is the reason why it is called 18650 cell. Uh, Suppose we take the example of one cell, a standard cell from Samsung, which is of 3.7 volts and 2.6 Ah. Okay, and we want to make a battery pack out of it. So we should know that there is a simple configuration that voltage increases as we put the cells in series, and current or capacity increases when we put them in parallel. Okay, so we need to know when we have to put series and when we have to put parallels. So here on the left side, you can see 2P, 1S configuration is there. That means two parallel cells are there, and each parallel is having one series. Whereas on the right side, you can see two series, two parallel configuration is there. Depending upon the requirement, depending upon the configuration, we can decide which configuration or which arrangement is appropriate for the application. Once the battery pack is made, it looks like this on the left side. Once we put the insulation, the enclosure on top of it, providing IP67 or IP6X rating, we can supply the battery packs, or we can serve the battery packs to the specific applications. Here you can see the detailed version of design of lithium-ion battery pack. I'll share the PDF across so that you can get a gist of what exactly happens. So initially the cell sorting happens. So cells are sorted depending upon the voltage and IR values. Then small battery packs are made, which are called modules. Once the modules are made, they are connected in series and parallel arrangement. The pack consists of some small battery packs, which are called modules. Once the battery pack is made, they are tested finally in various manners so that we can make sure that the reliability and accuracy is maintained. This is the detailed version of designing of battery packs. Here's the summary. So, right from the material processing to the second life, we will be having like knowledge throughout this process. Okay, so right from the raw material extraction, the ore extraction, where we are exploring which reserves to find, uh, which are the various metals that we can focus upon. Then we will be moving towards the cell production, where rare earth metals and some abundant metals or materials are amalgamated for making proper cells. In step three, small modules are made out of cells. Step four, small packs are made out of very small modules. And in step five, what we do, we integrate the pack with the vehicle through the assembly, through the integration part. And step six is once we have exploited the life of lithium ion battery, then around 70 to 80% of capacity is still left. And that uh, battery pack or those cells can be utilized for stationary energy applications, portable electronics, small toys. So there, cells can be utilized for various purposes. So in this way, the ore to door thing happens, and if we are not refurbishing the cells, the last option is to recycle them to extract the rare earth metals, to extract the dark matter out of it, and to make the cells again, to do this process again. So while buying lithium-ion batteries or while procuring lithium-ion batteries, what we have to make sure? So we have to check the warranty of it, battery dimensions, uh, to suit the application, which type of batteries we are targeting, LFP or NMC batteries, what is the make of the cells, number of cycles that is promised by the manufacturer, cost per kilowatt hour. So each year there is some cost difference and the cost is going down only. So that we have to make sure that we are updated with the current cost per kilowatt hour, exact voltage and battery capacity that is claimed, and what is required exactly. Company certifications and compliances, what certifications or compliances are being followed by the manufacturer, IP rating of battery casing. So normally IP67 or IP60X is followed. So that is typically for water or dust ingress, so that we can protect it. And last one is service and replacement policy. That in most of the cases in India, like many small assemblers are also there, which are directly exploiting customers in the name of making lithium-ion batteries, but they are not providing enough service and replacement support. So that is directly hampering the growth of EVs in India. This is the type of EV. So fuel based EV is normally called hybrid electric vehicle, where they work in like 50-50 ratio, you can say. In plug-in hybrid electric vehicle, only during the starting electric operation is there, or you can say the access to battery is there. And in 100% electric vehicle or battery electric vehicle, 100% batteries are used. Right now, this debate is peaking up that which one to use, sodium ion batteries are good or lithium ion batteries are good. So here you can see that sodium ion batteries are more abundant in nature and they are having good thermal stability, which makes them an obvious choice for EV applications or lithium ion battery, any energy application. Okay. So temperature range for lithium-ion batteries is minus 25 to 40 degrees Celsius, whereas for sodium-ion batteries it's minus 40 degrees to 60 degrees Celsius. Where apart from it, sodium is more abundant in nature as compared to lithium. So that enables any EV shareholder or battery shareholder to invest more in sodium-ion batteries. Recently, BYD launched blade batteries. So, what are these blade batteries? NMC batteries, when penetrated with nail, they uh, uh, push out the sharpnels. There is a thermal runaway process, and the chain reaction increases, which leads to the fire and fumes and flames. For regular LFP batteries, only smoke comes out, no fire, no flames, and no sharpnels are coming out. Whereas for LFP blade batteries, even the smoke is not coming out. So the reason or the scientific principle behind it is very simple. The spacing between the cells is increased, which increases the level of heat dissipation that is done. It lowers the chances of short circuits between the cells. So, and they have made this chemical composition in such a way that no chain reaction happens because no oxygen is released during such thermal runaway process. Although it increases the overall size of the battery, but at the same time, it adds the life to the battery, it adds the efficiency and reliability factor to the battery. Yeah. So, coming to the most funny, or you can say most dangerous part of lithium-ion batteries, and that is lithium battery fire. Okay. So why it is happening? how we can make sure that this will not happen, and what are the key measures that we can take. So first one is lithium batteries are rising. We know the advantages of it: higher energy density, more charge discharge cycles are there, low self discharge rate is there. So low self discharge rate is, suppose you are putting battery today at a particular temperature at a particular location, and after 1 year you are coming and you are checking the voltage. If the voltage difference is not that much high, that means the self discharge is low as compared to lead acid batteries, nickel cadmium, nickel metal hydride. The lithium ion battery self discharge is very low, and that directly uh, increases the chances of its applications across the corners. Fourth advantage is dropping prices are there, so that is directly helping the adoption part of it. Coming with its own cons. Okay, so safety hazard issue is there. It always needs external monitoring so that we can make sure that the predictive or proactive maintenance is there. Third one is it's still expensive even after years of adoption. And fourth one is the technology is yet to mature. So our normal random garages or random battery service people, they don't know much about lithium-ion batteries, and that is directly hampering the resale of lithium-ion batteries. That is directly hampering the repairing and serviceability of lithium-ion batteries. So these are some newspaper cuttings of the EV fires that took place in last 2 3 years. So here you can see that uh, NMC is the culprit. So for NMC batteries only, the safety is the highest is of highest issue. Okay, and I have compared all the types of lithium chemistry batteries here so that you can easily get a gist of which battery is suitable for which type of application. So, if we dive deeper into that thermal runaway incidents part, uh, let us know the reasons behind it. So, internal short circuit, external short circuit, overcharging or over discharging, high temperature exposure, or mechanical abuse. So, mechanical abuse also consists of the accidents that the batteries or the EVs go through. So, these are some typical reasons which can be easily understood by a layman uh, for understanding why these thermal runaway incidents exactly happen. So let us know the standard reasons which are directly hampering the adoption. Okay, so design methods are substandard, quality concerns are not shown by the OEMs, by the key players in the EV industry, lack of knowledge and skills is already there. So I'll like to thank Gyaniki and other folks who are doing incredible job in creating the awareness part of it. And last one is extreme conditions. So during extreme conditions, uh, people don't know how to react to lithium-ion batteries. Okay, so we are not trained enough. We don't have the enough knowledge about it. Design methods are faulty or substandard, and quality concerns are still not there. Here you can see. So most of the EV fires which happened in India uh, at uh, most of them happened when the vehicles were during the park stage or in the charging state. Okay, and in both the states you can see that there are high chances of ambient conditions affecting the chemistry of it. Okay, so when we charge or discharge the battery, the recombination occurs, so the battery gets heated up. But when it is coupled with the external temperature and there is no proper insulation, or you can say thermal insulation, it directly hampers the reactions which are going inside the lithium-ion batteries, and the that separator gets broken, which directly increases the chances of thermal runaway. So here you can see the separator gets broken, the SEI layer, that is the, like you can say, the separator of the separator. Okay, there is a thin layer in the separator that is responsible for the life and safety of the battery. So if you can estimate the thickness of SEI layer, you can directly tell about the health or safety levels of the battery. As the SEI layer decomposes, there are high chances of the temperature getting increased further, and the oxygen is released. So this chain reaction continues, and the heat, the sharpness, the warming up process continues, which directly leads to the explosions and which directly hampers the growth of EVs or EV batteries in India. We conducted some experiments in association with IIT Gandhinagar where we intentionally put some batteries on thermal runaway stages, and we figured out that there are some electrical equivalents. If we know such electrical equivalents using machine learning, we can easily identify how electrical equivalents, when changed in a particular pattern, can help us to identify what parameters will eventually change. Okay, so as the battery leads to any kind of thermal runaway process, or if there are any chances of harm inside the battery, then it first uh, directly changes the values of voltage and current. Okay, so we constantly monitor the values of voltage and current during the charging process while the batteries were put on fire. So here you can see that within few seconds only the black smoke came out, and within the interval of that 20 seconds, the last flame generation was there. So it doesn't give that much time to react, to run away, or to take any action. Okay, so that black smoke is the warning, and the last flame generation is the big action. Okay, here you can see. So as the temperature increased, the voltage went to zero. Okay, and it constantly went to zero after some intervals. Okay, when the temperature was increasing, so it directly hampers the SEI layer. Okay, as there are high chances of thermal runaway, there is lithium plating on SEI layer surface. There is dendrite formation on SEI layer surface. So using machine learning, what we are doing, we are estimating the level of SEI layer decomposition. Okay, how we can do that? So we have onboarded Judy Jivarajan ma'am. So she was working in NASA previously in the battery safety division, and right now she is working in Underwriters Laboratory as a research director. She guided us that if we know the DCIR uh, profiling, okay, so DCIR is DC internal resistance. As the SCI layer gets thick, uh, as the battery ages, it directly hampers the values of DCR resistance. Okay, if we know the DCR resistance in an accurate manner, we can easily classify which batteries are of which type, which batteries have which kind of anomalies, and that will directly help us to identify the health, the safety, performance, and faults in a faster manner. So using that, we made sure that we are leveraging that, and we are helping EV and others shareholders for taking better decisions with batteries. Okay, now coming to diagnosing the batteries. Right now, the diagnosing part starts with the visual inspection process. As we all know, we have to examine the battery pack, like what physical damage is there, are there any dents, leaks, corrosion, or any other swelling marks where you can easily infer that this battery is not performing well or has not performed well. We have to also make sure that the connectors are fine, the connectors are not loose, damaged wiring is there, any signs of overheating or overcurrent, or you can say any chemical uh, or any leaks are there. So all visual stuff which you can easily identify can be included in this visual inspection process. Second one is to test the pack constantly. So there are various instruments or measuring tools which are directly helping EV or battery businesses for getting the test done. So you have to make sure that you are using a standard tool for getting the battery tests done. Third one is to check the string voltages. So as the batteries are arranged in a series parallel manner, you have to make sure that the voltages are same in the parallel and the current is same in the series. Okay, so that you can easily repack them, you can easily repair them, you can easily service them. Fourth one is the balancing of cells. So As the battery gets in more application, it gets more use. There are high chances that there are some leakage currents, and at times the voltages are not same for the cells in parallel. Okay, so due to that small voltage difference, there is a leakage current, and that directly hampers the performance of battery. It also might lead to range degradation. It also might lead to some kind of you can say uh, performance degradation, okay, which you can easily feel. So cell balancing is also a process where you have to make sure that we have an active or passive balancer so that all the cells have the voltage and IR values same when they are in uh, parallel manner. At last, what we have to do, we have to repack the pack and test it again and again so that we are making sure that once the pack is repacked, we have to check the voltage of it, check the capacity of it, check the performance, safety, and health of it so that we can take better decisions with it. Now, coming to the real life problem. So, I have talked a lot of theory in past slides. Okay, now I'm coming to the real problems which the India is facing as of now. Okay, so first thing is quality concerns are already there. We have seen a lot of videos where people are abusing brands, people are saying uh, various strong stuff about EV brands because they are not getting good quality as compared to the IC engine vehicles which they are buying. Second one is bad service support is there. Even though the dealerships are there, uh, due to lack of skills, due to lack of awareness, the dealerships are not providing enough support so that customers are not happy. And then once they buy an EV, then they are not ready to buy another EV because of the support that they got from dealerships or the brands. Third one, still there are potential risks. So I've seen one guy who was dragging his vehicle in the parking away from an electric vehicle because that was an electric vehicle. Okay, so there is a notion that this is an electric vehicle and it might catch fire, so that directly can affect my vehicle's health. Last one, uh, like lead acid batteries, we still don't know the resale value of lithium ion batteries. So if you return a lead acid battery, you will get some refund or some discount, whereas for lithium ion batteries, it is still not there. So quality, support, risks, and resale value. These are unknown and people are trying different stuff. So they have CDC machines. So these are some bulky machines where you have to put your battery. It will at least take 7 to 8 hours for getting the test done. You will simply get voltage and capacity only once the test is done. And you have to put one guy there who will be writing down all the readings. So he'll be constantly writing the voltage and capacity and current readings. Once the test is done, you will get voltage and capacity only. There is no idea given about the health of the battery, about the safety of the battery, about the faults inside the battery, about the performance of the battery. So only voltage and capacity, and this is almost 15-year-old, and still people are using it. So even the the testing agencies in India are using such machines, which are very costly, which are imported, which are not having any service centers in India, and still they are testing it because they are old ones. Okay, this is our magnum opus. This is our product that is called EV Doctor. What we are making sure is anybody can take better battery decisions using this device. It is 8x faster, so we have incorporated all the crucial machine learning algorithms so that they don't have to worry about the knowledge gaining part. They don't have to worry about the calculations part. They have to simply connect the battery. Once the test is done, all the crucial results about the health, performance, safety, faults is available on the app, and depending upon that, they can take better decisions. It is reliable, so we have constantly tested it across the industry with the standards of the industry. It is CE certified, ROHS certified, which directly enables it to become a global player in the battery testing industry. How this works? It works on the principle of DCIR and voltage current profiling. So what it does, the device is used for data acquisition part. It takes the values of voltage, current, and time. It feeds that to the cloud. where we have our algorithms at place. The algorithms do the magic. So we have both type of algorithms, machine learning based algorithms, and we also have battery specific models. They perform in parallel so that we can get the utmost accuracy and reliability factor out of it. And once the test is done, so within 15 minutes, the test is done, and all the crucial results are available on the app. They don't have to worry about checking the batteries again and again. Once the test is done, whenever they want to check the battery, they don't have to make sure that there is a guy sitting there. Only limited insights are provided, or you have to wait for some long hours. So say within 15 minutes, once they have the, meanwhile, they can get the test done. This is the tech innovation part of it. So we have 22 plus, right now it is 25. So 22 plus custom machine learning algorithms. So XGBoost and X-Kalman, extended Kalman filters we have used for SOC and SOH prediction. K-means and Gaussian matrix model we have used for behavior analysis. And random forest and support vector machines are used for anomaly detection, or you can say fault detection part. We have data sets of more than 5 lakh plus lithium ion batteries. So these are all real time data sets. So that is directly enabling us for getting better on the accuracy and reliability front. Uh, it is tested both for LFP and NMC battery types. We have training data from more than 30 plus giant EV OEMs. And with each test, the accuracy improves. So that directly enables every other guy to take better decisions with EV batteries. This is how it looks like. So, as I've said, the magic happens on the cloud. So, we have intentionally not filed the patent. I have like 7 patents under my name, but for this, we have not filed the patent as the magic is done on the cloud part. On the right hand side, you can see the sample report where the health is there, the safety levels are there, the faults, like the number of faults that we have provided. And at last, you can see the performance parameters. After that, you can see battery health parameters, safety levels, fault status, and energy parameters in a detailed way. So, using this, anybody can take better decisions with the EV batteries that they have. We are constantly making sure that the cost is coming down for of this device, and we are constantly making sure that this gets democratized across the world. This is totally an indigenous technology. We have not imported even a single screw for this product. We have made sure that we are constantly sticking to the goal of really inventing, designing, conceptualizing, developing, manufacturing in India. This is the uniqueness and value proposition part of it. So this is commercial slide. This is the comparison of CDC machines and the EV doctor. So yeah, I hope I did some justice to the time. I'm open for the questions.
Yeah. Thank you so much, Shubham. It was a really great presentation. And yeah, so we are in time. Any questions? So, Shubham, just let me tell you, we also have more 15 people sitting at one place. So they are also together, and the 20 participants here, right? So we have a quite a good number today. Just would like to understand. So we have a few questions already received, and we have few questions from our participants also. So two things. First, I would like to know. So this product is it the only used by the OEMs or dealerships, or anyone who is owning an electric vehicle?
This is for dealerships and companies only. The one who are owning it, they have to simply go to the dealerships and ask whether they can get the battery check done with EV Doctor or not.
Okay. And then the next question would be, say, this product which you have developed, is it only useful to create a report of the battery pack, or you can also have predictive maintenance and the resolving issues related to the software. I know the mechanical and electrical stuff need to be done manually, but then
Correct, correct.
uh, regarding the logic level, how it is working.
Okay, okay. So for that, we have a separate entity that is called Energy AI Labs. Okay, where we are working on the predictive and proactive maintenance only, using machine learning, like state-of-the-art machine learning algorithm. I have put the link over here, so anybody can refer to it. There we have the API version of all the parameters that we have developed till date.
Understood. So, what predictive algorithms you have, if you can just give some logic level insights,
Okay,
what
so
type of predictive algorithms you have used? So you said there are 25 around algorithms which you are
yeah,
using,
yeah,
right?
yeah.
Okay.
Correct, correct, correct. So I'll share the major ones. Okay, so
Yeah.
we are using random forest, ANN, uh, then SVR, K-means, Gaussian, extended Kalman, then XGBoost. So these are some major algorithms that we are putting them in place, and coordinating across them is a major task. Okay, because you might get accuracy in 2 out of 5 of such algorithms, but making sure that all the algorithms are having an aggregate accuracy of more than 97% is a very tough task, even if you have a lot of data. Okay, so right now we have a lot of data, but we are constantly training our algorithms so that the reliability and the accuracy and the dependability part is high.
Okay. And what level of prediction we can have through this?
So
So
what level of
in a
prediction
sense,
means?
performance or maybe the safety, the health, or the already say the historic cycles and the performance data which it stores,
Yeah, yeah,
say
yeah.
from the
So
BMS.
correct, correct. So it includes the battery safety, it includes the battery health, it includes battery performance. So performance includes SOC, SOH, voltage, current, continuous charging current. So all such things are covered in the performance side. And in some part of it, we are covering range also. Apart from that, the anomaly detection part is also so these all parameters. I'll be like sharing some basic stuff.
Yeah.
So if you see any battery tester, it is based on built-in function. Okay,
Yeah.
like built-in function based. Okay, so there is some logic that is already assigned to the PCB, and that is constantly performing that logic only. Whereas for EV Doctor, what it does, constantly the estimation is there. So whatever parameters you see on the report, all of them are estimated only. Okay, none of them is directly calculated. So during the test, the calculation, or you can say the measurement happens. Once the test is done, the magic of AI uh, get started. Okay, so all the parameters that you see on the app, all of them are estimated, and all of them have an average accuracy of more than 97%.
Got it. Uh, Great. Yeah, I guess that gives my answer. Now we have one more question from our participant. So the question is, can we test in a vehicle or remove? I mean, the battery has to remove from the vehicle.
Uh, it is both the ends. Like you can test it within a vehicle also, and you can remove it also, and you can check. So it's very simple. You have to simply I'll share the
Yeah, if you have some demo
well,
video to share here,
yeah,
how
yeah,
the
yeah, yeah,
process
yeah.
works,
That will be
so that
yeah,
will
yeah.
be
That
great
will be
for the
better.
audience. Yeah,
Mhm.
EV Doctor,
yeah,
the
it's there.
revolutionary AI powered solution that's transforming battery diagnostics, powered by advanced DCR computations, over 20 state of the art AI algorithms, and an extensive database of over 200,000 battery datasets. Here's how it works: connect the battery, attach our handheld device, and run the test through the intuitive EV Doctor app. Finally, connect the charger. After the test, You get the insights about the health levels, safety levels, performance, and crucial faults. These results assist you in taking best decisions for the batteries. EV Doctor is a CE certified and tested by over 100 battery experts, proven to prevent hazards in more than 1 lakh plus batteries. Trusted by over 100 EV brands and 1,600 workshops worldwide, including in India, USA, and Mexico. Enhance your battery quality control, service, and repair capabilities with EV Doctor.
Yeah, so uh, you don't have to worry about the testing part of it. So you can hello.
Yeah. Yeah.
Yeah, yeah. So within vehicle also you can test. Outside the vehicle also you can test. You have to simply connect it between battery and charger. So while you are charging the battery, you have to simply connect battery EV doctor in between.
Understood. And now the question is, using this, is it only the battery pack performance and the health we can check, or is there or any algorithms or machine learning there to know the chemistry health? You know, because this is good. You what you are saying or your product says that the battery life is being saved. Now,
Hmm,
definitely, that will be an advantage of the second life of the batteries, correct? Or second
correct.
life, third life. And that is
Hmm,
where it's not only the capacity which is fading, but the also the quality of the elements, or you can say the chemistries, which is reducing. Now,
hmm,
is there anything which can also says that okay, the health of lithium or say the anodes and cathodes are okay, not okay, the type of
hmm, hmm.
extraction possible or not possible, something like that?
Yeah, yeah, yeah. So this is a very good question. So what exactly happens? Just like humans have spine, this lithium-ion batteries have SEI layer. Okay, so
Yeah,
that SEI layer is directly signifying the health of the battery, or you can say the life of the battery. Okay, so as
yeah,
a person ages, the spine ages accordingly, right?
yeah,
So
yeah.
so obviously we can comment that electrical parameters might fade and chemical parameters might remain same, or it might be the reverse side. Okay, that the
Yeah.
chemical might phase and the electrical parameters might remain same, but that is totally not possible. Okay, when chemical parameters are eroding, it will directly hamper the electrical parameters, and they have a linear relationship. Okay, so that's why we have introduced, like, that's why we have included battery specific models also. Okay, so this is not just reliant on estimation or classification algorithms. It also has battery specific algorithms. So the XGBoost and extended Kalman, these are battery specific, not just machine learning specific.
Now, one more question we have from Ms. Kalaivani. So, Kalaivani ma'am has asked, how can we repair battery packs through this?
Okay,
I mean, what
so
are the
once the
parameters
test
which
is
gives
done,
like? Yeah,
yeah,
go
yeah.
ahead.
Yeah. So yeah, you can, so one, you can Google EV Doctor and you can see the report where all the crucial parts which are helpful for understanding the current status of the battery are already there. So specifically for the repair parts, without opening it, how can we know that it has water damage? How can we know that it has BMS issue or deep discharge issue? So all such faults we have already covered. So without opening, you can test it with with the EV doctor, and accordingly you can replace or repair the individual components of it.
That's sure. Okay, thank you. So, okay, next one or two question from my side, Shubham. Will not take more time. So, one thing which I want to ask is, do we need, or I mean, first, this product is only specific to the NMC chemistry, or it can go with any lithium chemistries or any battery
Yeah, it
chemistries?
right now it goes for it works for any lithium chemistries, and we have included lead acid batteries also.
Okay. And then, do we need, I mean, any training or the any experience is required to diagnose the battery pack using this EV Doctor device, or you provide a training around it to your customers,
It's
dealerships
a
or the
it
OEMs?
Yeah, it's a simple plug and play device. So just like people connect Bluetooth speakers to the mobile phones, similarly they can connect the EV Doctor and get the tester.
Okay.
Yeah, although we
Understood.
provide demonstration, detailed video, and we also provide manuals for it, but it is intuitive, so they don't have to rely on any manuals.
Yeah. Okay, understood. So I guess, ma'am, I can probably give you the answer. So there is a question from Kalamani ma'am. So it definitely the batteries are repaired by the OEMs or the dealerships only, and that is where this product is used. That's what Shubham has already explained, right? The
Yeah, so
product
I
goes
have
to the
I've shared
dealerships.
the demo. I've shared the
Yeah.
detailed demo video here, so that the ma'am can easily understand how it works and how without opening the test can be done.
Yeah. Yeah. Okay. And last question from my side, Shubham, how your business or how you work with the clients, to understand, because we have a few of audience here who is working with the industry as directly with the manufacturer or, dealerships, or you can say the tier ones kind of a thing.
Mhm.
So, I mean, do we need to buy it, or it is also available on a rent model? The reports which are generated is owned by EV Doctor, or it is the IP of the companies?
Yeah. So it can be easily bought directly from us, and we don't have any subscription model as of now. But simply they have to buy it, and we provide the warranty, support, everything.
Okay, and then they have their own portal where reports are being generated and they can use it.
So it is generated on the mobile app only. Simply any Android or iOS system it supports.
Yeah, understood. Yeah, I guess so. Yes, ma'am. So service person definitely can take the training, and trainings are being provided by the team of the EV Doctor. Yeah. So any more questions, you can either write to us. Shubham, I hope we will post this video on the YouTube also. So uh, other Gyaniki subscribers can also take advantage and benefits of it, right?
Sure.
Yeah. So I guess we are at the end of our session today. And thank you so much, Shubham, for your time. And we are very thankful for you and for your time. It's a great product.